In the 1980s and 1990s, a new chapter in AI began with the rise of machine learning. This brought significant changes to the field, making AI capable of far more complex tasks. One of the key breakthroughs was the backpropagation algorithm introduced in 1986 by Rumelhard, Hinton, and Williams. This algorithm allowed neural networks to learn more effectively by adjusting their weights through supervised learning, leading to much better performance. Imagine you're teaching a child to throw a ball into a basket. If the ball misses the basket, you give feedback on what went wrong, like you need to throw harder or aim a little higher. The child then uses this feedback to adjust their next throw. Backpropagation works in a similar way for neural networks. Here's the process. Forward pass. The neural network makes a prediction based on the input data. This calculates outputs layer by layer, from the input all the way to the final output. The network's guessed output is then compared to the actual correct answer, the target output, to see how far off it is. This difference is called the error or loss. Backward pass. The error is sent back through the network. And this is exactly where the term backpropagation comes from. The algorithm calculates how much each neuron contributed to that error, just like figuring out which part of the child's throw went wrong. This information is then used to adjust the weights, the strength of the connections between neurons in the network to reduce that error. Weight update. The network adjusts its weights, much like the child adjusting their throw, to minimize the error. This adjustment process uses a method called gradient descent, which systematically tweaks the weights in the direction that reduces the error the most. Repeat. This entire process is repeated many times with different data. Each time, the network gets better at making accurate guesses, just like the child improves with continued practice. In summary, backpropagation is like a feedback mechanism that helps a neural network learn from its mistakes by adjusting its internal parameters to improve future predictions. So, where is backpropagation used currently? This algorithm is key to training neural networks, and it's widely used in all sorts of real-world applications. For example, it helps systems recognize images, such as identifying faces in photos or detecting diseases in medical images. In natural language processing, backpropagation is crucial for tasks like translating languages and powering chatbots. It also allows self-driving cars to understand and respond to sensor data for safe driving. Additionally, backpropagation powers virtual assistants like Siri and Alexa to understand and respond to spoken commands. In the financial sector, it helps predict market trends and automate trading decisions. These examples show how backpropagation is used in countless industries to solve a variety of complex problems, making it a foundational element of modern AI.